Hello dear students, in today's video we are going to discuss about different types of chemical reaction. See, we have already seen discussed about chemical reaction, what is chemical reaction and what are its information that we can get from a balanced chemical equation. And now we are going to discuss about different types of chemical reactions. So we can classify the chemical reactions into different categories. That is combination reaction, then decomposition reaction, then displacement reaction, double displacement reaction, then redox reaction. So, first of all, we will talk about combination reaction. Combination, the word itself means combine. Combination means combine. So, in a general way, we can represent that A plus L reaction is AB. So that means two reactions combine. So during this particular reaction, that is general characteristic of this particular chemical reaction. During this chemical reaction, what happens? Two separate reactants, they combine to give a single product. This is what happens. The way we can represent it, A plus B reacts to the AB. That's the product. So this is the general characteristic we can see. In example, occasions of oxide reaction, that is again carbon monoxide and hydrogen reaction. Then very similar example. Slate cut line will be produced, that is calcium hydroxide. Calcium hydroxide. So we need to take care of that. Exo means out, thermic means heat. Exo means out, thermic means heat. Or during this type of reactions, heat energy is released. Okay, so these are some examples of combination reactions. Hello dear students, in today's video we are going to discuss about the second type of chemical reaction, that is called decomposition reaction. It is just opposite to that of combination reaction. So in a combination reaction we discussed that two reactants combine so as to give a single product. Here just opposite to that of combination reaction, the word itself, the decomposition. What do you mean by the word decomposition? Decompose. So the single product, a single product breaks itself into two or more different substances with the help of heat. Here an external agent is required, energy should be supplied in order to break a compound. So you can see certain examples here. The general format of this particular reaction, general equation we can write like this: AB reacts to give A plus B. The single product AB that breaks up itself into give two or more simpler products. One example you can see, ferrous sulfate. When you heat ferrous sulfate crystals in one of the activity we have already seen that heating of ferrous sulfate crystals. So it is of green color that will turn somewhat reddish brown color, ferric oxide, and with the formation of sulfur dioxide and sulfur trioxide gas. So you can smell that gas by wafting your hand just near to the mouth of the test tube. So you will smell the burning smell of sulfur. It will be observed. See the next equation, the burning of or heating of calcium carbonate. When you heat calcium carbonate, what happens? It will decompose to give calcium oxide and carbon dioxide. So this equation, this chemical reaction, this decomposition reaction, which is also very useful in different industry, mainly in cement manufacturing industry. So this reaction is very important. The next decomposition reaction, one example is lead nitrate. Decomposition of lead nitrate, where you heat a small amount of lead nitrate in a test tube. So it will decompose to give lead oxide, nitrogen dioxide, and oxygen. So the nitrogen dioxide, this gas will be somewhat greenish color. So you can observe the evolution of this green color gas, nitrogen dioxide. So that's an observation here. So these are some of the examples of decomposition reaction. See, you look at all these equations here. Above the arrow mark, we have written heat. So what it signifies? In order to carry out all these chemical reactions, we need to supply heat energy. So in order to supply the heat energy, so these all reactions absorb heat energy so as to break themselves into simpler substances. So such a reaction, that is just opposite to the reaction which we discussed in the previous video, that was exothermic. Now these require energy. So they are termed as endothermic reaction. Endothermic. Endo means in. It takes in. Thermic means heat. So in all these reactions, heat energy is absorbed. Energy is required in the form of heat energy. So that's why these chemical reactions are termed as thermal decomposition reactions. These reactions are known as thermal decomposition reaction. So thermal energy is required in order to carry out these chemical reactions. So these are also known as endothermic. Endothermic means we need to supply energy in order to carry out these reactions. Okay, thank you. Hello dear students, in this video we are going to discuss about another type of decomposition reaction that is known as electrolysis. Electrolysis of water. See, what do you mean by electrolysis? Electrolysis is also a type of decomposition reaction in which a single reactant breaks up into two or more different substances as a product. See, here you can see water we are taking in a mug, and at the bottom we are making two small holes and we are inserting two graphite rods as anode and cathode as electrodes. The graphite rod which is connected to the positive terminal of the battery, that is known as anode, and the graphite rod that is connected to the negative terminal of the battery is known as cathode. So, and we are taking water in the cup and we are adding few drops of hydrochloric acid to this water in order to make the water more conductive. So as you switch on the device, what will happen? Current will start passing through the solution, and as a result water molecule H2O will break up into give hydrogen and oxygen gases. So the hydrogen gas that will be released, H plus, as hydrogen gas that will be released at cathode, as cathode that is negatively terminal, negatively charged terminal. So hydrogen gas, H plus ions present in the water, so that will move towards cathode and it will get released at the top of cathode. So what happens as water molecule breaks up in the presence of, say, acid. So it will break up into H plus and OH minus ions. Then OH minus ions further breaks into gives O2. O2 gas. O2 gas, oxygen. Oxygen as they lack electrons. So they need electrons in order to complete their octet. So they combine so as to they will move towards positively charged electrons and electrode, and they will get released at anode. So when you compare the volume, the ratio of this particular gas, so that will be, here you can see hydrogen gas that is released, that will be little more, twice the amount that of oxygen gas, because in a molecule of water we can see there are two atoms of hydrogen and one atom of oxygen. So when you break up this water molecule into hydrogen and oxygen, the same ratio we will get the volumes of hydrogen and oxygen. The ratio of hydrogen and oxygen as gas, that also will be 2:1. Here also we can see the ratio between hydrogen and oxygen in a molecule of water, that is 2:1. The gas, the released gas, if you take the proportion of the released gas, then also we will get the same ratio, that is 2:1. The amount of hydrogen gas, released will be twice the amount of oxygen gas released during this phenomenon. This process is known as electrolysis. So what do you mean by electrolysis? Electrolysis is the process of breaking a compound by using electricity. Electrolysis is a process of breaking a compound into its constituents by using electricity. So this is also a kind of decomposition which uses electricity as energy. So they are known as electrolytic decomposition reaction. Electrolytic decomposition reaction. Many salts we can, salt solutions we can decompose like this, electrolysis. So that process is also used for obtaining pure metals, and this is the process. Hello dear students, this video we are going to discuss about the third category of decomposition reaction, that is known as photo decomposition reaction. So photons, photo means light, photosynthesis we already discussed, but that particular term photo means light. So we already seen that in order to carry out decomposition reaction we need to supply energy. So in this situation already we have discussed about two types of chemical thermal decomposition reaction, then electrolysis, electro-decomposition reaction. Now the third thing is photo decomposition reaction. See, you can see that sunlight that we obtain. So it is also a form of energy. So in this type of reactions, there are certain compounds that can break up to give similar products in order even in the presence of sunlight. By using the energy from sunlight, these reactants, especially these two substances, silver chloride and silver bromide, especially these compounds can break up to give silver and chlorine gas. So they will turn somewhat grayish color, so when they are exposed to sunlight. So this particular reaction, these chemical reactions, silver bromide and silver chloride breaks up to give silver chloride and silver and chlorine gas and silver and bromine gas. So this reaction is widely used earlier days in black and white photography. So in this type of reaction, the light energy is used. When these chemicals, when they are exposed to sunlight, light energy will absorb that light energy, and with that energy they will use and break up to give silver and chlorine, two similar products. So a single reactant breaks up to give two similar products by using sunlight when they are exposed to sunlight. So this type of reaction, They are known as photo decomposition reaction. Here photo means light. Here we are supplying energy in the form of sunlight. Sunlight. The energy that is present in sunlight, that is utilized by these compounds in order to break themselves into two simpler substances, silver and chlorine gas, silver and bromine gas. So that's why they are known as photo decomposition reaction. Photo decomposition reaction.